Alright, so in order to graph linear inequalities, what you're going to do is you're going to write the inequality in y equals mx plus b form, or you could write it out in word form. It just kind of depends. Okay? The next step is to graph the inequality. You're going to use a dashed or dotted line for greater than or less than symbols. And you're going to use a solid line for greater than, less than, or equal to symbols. So if there's not a line, you're going to use a dashed line. If there is a line, you're going to use a solid line. You're going to use a coordinate point to determine which side of the line to shade. I'm going to show you this in just 1 second. The inequality symbols, okay? So if I had these two numbers written, I would read this as 5 is greater than 3, right? So this inequality symbol is greater than. Okay? If I wrote this, it would be less than. 2 is less than 3. Less than. For this over here, I would have this, and I would read this as 8 is greater than or equal to x. And this last one, I would say 3 is less than or equal to 5. Okay, so this little box down here at the bottom, this is something that you can either memorize. I never personally memorized this because this always confused me, but you can if you want to. If you're going to use this box, though, you've got to make sure that x is on the left-hand side of any kind of inequality. Yep, I was just going to highlight, but that's cool. So you say that x has to be on the left side of what? X has to be on the left side of any inequality. So it has to be written where x is on the left-hand side, okay? So, for instance, this shade above, I don't know if y'all remember from Algebra 1, but like if you had an inequality where this was your line, and then you were told to shade above, you would shade above that line, right? Yeah? Oh, yes. Okay, we're going to see that, okay? And that's what this is saying, that you have to memorize which way it's facing, and if it's greater than, you're going to shade above. If it's less than, then you're going to shade below, okay? And again, you can memorize it this way. I don't, but that's okay. I'll show you how I do it in just a second. All right, so go ahead and flip the page. So you've got two inequalities, and we're actually going to graph these two inequalities on the same graph. So first thing that we want to do is write it out into y equals mx plus b format. So on this first one, we would have y equals negative x. Pretty simple. Looks like the inequality, but there's an equal sign in between. Okay? So if we're going to graph this old school, what's our y-intercept of this? 0. Okay? So then we're going to go down 1 and to the right 1. And the reason why I'm going to do that is because it has a negative slope. So I'm going to go down 1 to the right 1. Down 1 to the right 1. And I'm going to continue that process. And I'm going to create that line all the way. The reason why I can go the opposite direction is because I'm going up 1 to the left 1, right? Why do you want to stop? Because I want to create a whole line. Yep. Now my question to you, is this going to be a dashed line or a solid line? It's going to be a solid line. Okay, and the reason why it's going to be a solid line is because there's a line underneath here on our inequality. It's going to be a solid line. So we're going to connect these points as straight as I possibly can on this. Listen, just let me live my life. Okay? Now we're trying to figure out whether we should shade up or down. And this is where I use my technique. Okay, he's saying shade down. Okay, but let's check and make sure that he's right. So if I plug in the point 1, 1 into my equation, if I plug in the point 1, 1 into my equation, or my inequality, is 1 less than or equal to negative 1? Yeah. It's not, right? Yeah, I'm asking you. Is 1 less than or equal to negative 1? No, it's not. Okay, so we're going to shade away from the point 1, 1, which is right here. Yeah? On the opposite side. So I'm going to shade this way. Okay? Now, this inequalities, you're going to have to deal with some erasing. So I would always try to do it in pencil if you can. Okay? So let's try this next part. Okay? So for this inequality, we're going to graph it. Okay? It's already in that y equals mx plus b format. So we're going to go where x is 3. And we're going to draw a vertical line. Now, is this line going to be solid or dashed? It's going to be dashed because there's no line underneath here, right? So we're going to draw a dashed line. Okay? That's on 3, yep. Yep, it's a vertical one. Okay? So this has just an x, right? So if I graph the line x equals 3, that's a vertical line, right? That's it. Okay, so now which side do we shade on? Well, let's pick a point. Let's pick a point. 6, 0, right here, right? So let's plug that in. Is 6 bigger than 3? Yeah. So I'm going to shade the side that includes. So that's going to be over this way. Yes. So if I plug in 6 into my equation and it's a true statement, I'm going to shade towards that point that I just picked. Go to the other side. Okay? So, do you see where there's this yellow over here? And we said the green is over here, we're shading this way, right? But we only want to include the stuff that they cross over. So all this extra crap that I have over here, we're going to get rid of. Okay? And this is why you want to do it in pencil, because you're going to have to go back and reshade. Yep. I know, I see you. So your final answer, and it's okay if you want to just do this. Look, it's okay if you want to leave it like this. Or if you want to leave it like this, where you say, hey, I'm going to shade down from this one, and you see where they cross over, and then I'm going to shade to the right for this one, and you see where they cross over. Like, I can tell from this that this is your final answer. Okay? So we're shading up from that one, and then we're shading down from the other one, right? That is both of these inequalities. That's where they're going to cross over, right? So it's going to be in this space right here, okay? So let me pick a point that's in here, okay? So let's say 5, negative 8, okay? So a solution to this problem would be 5, negative 8. My question to you, is the point 3, negative 7, is that a solution? 3, negative 7. Is 3, negative 7 a solution? No. Why? It's not in the shade, but also it's on the line that's on the dashed one, right? And that's not included, right? Okay? So it's not a solution. 3, negative 7 is not a solution. What about 5, negative 5? Look at this point right here. 5, negative 5. Is that a solution? Is it on a solid line? Then it is a solution. 5, you go ahead. solid line or in shading area. Okay? Go ahead and look at the next problem. So in this one, we're going to put this in y equals mx plus b format, right? Which is going to be y equals 4/3 x minus 2. So I'm going to graph this. I'm going to say negative 2 is my y-intercept. I'm going to go up 4 and to the right 3. And I'm going to repeat that process.
Up 4 and over 3?
Yep.
What point?
Negative 2. Because negative 2 is my y-intercept. Okay? Now, up 4 over 3. Is this going to be a dashed line? Is it going to be dashed or solid? It's going to be dashed because there's no line underneath, right? Okay, so I'm going to dash my line. Start at negative 2 and you go up 4 over 3. Okay, now are we going to shade above or below? So let's pick a point. I personally like 0, 0. Okay, so we're going to take 0, 0 and we're going to plug it in. If I plug 0 into y and I plug it in for x, okay, I'm going to get 0 is less than negative 2. Is that a true statement? Is 0 less than negative 2? Is 0 less than negative 2? No, it's not. So that means that we're going to shade away from 0, 0. Okay, question so far. So we're going to take this equation and we're going to put it in that y equals mx plus b format. Okay, and we're going to start at negative 3, which is what our y-intercept is. And we're going to go up 1 to the left 3, or we're going to go down 1 to the right 3. It doesn't matter which way you go, as long as it has a negative slope.
What you say, down 1?
Down 1 to the right 3, or up 1 to the left 3. Okay, is it going to be solid or dashed, Marley? It's going to be solid. So it's going to be solid. Okay, and now we're trying to figure out where we're going to shade, right? So we're going to plug in 0, 0. Okay, if we plug in 0, 0 into our equation or inequality, we'd get 0 is greater than negative 1/3 times 0 minus 3. If we simplify this, that's saying 0 is bigger than negative 3. Is that a true statement? Yeah. So we're going to shade towards 0, 0. Okay. Now, do you notice how this area over here is shaded with both colors, right? So that's going to be your solution area, right? Okay. So let's name a solution. Go ahead, Zach. 3 what? 3 negative 2 is a solution. All right. 6 negative 1 is 1. Okay. Eliza won 40 lollipops playing basketball at the school fair. She gave 2 to every student in her math class. How nice. She has at least 7 lollipops left. Write an inequality to represent the situation. Be sure to define a variable. Okay, so here's the deal. Our first period did it one way, but here's the deal. You've got to actually read the problem. You see how it says at least 7 lollipops left? So it's got to be bigger than 7, right? Now, is it equal to?
Yes.
Okay. All right. So we're going to put,
What is that?
I don't know. That was crazy. So greater than or equal to. Now, what am I going to write on this left side? Well, it tells me that she starts off with 40 lollipops, right? And then homegirl started passing out lollipops 2 to a person. So she's going to subtract 2x, right? Okay. And x is going to represent the number of students in her class, right? So x is going to be the number of kiddos in her class. Okay? Maximum number of students in her class? Yeah? Okay, so that means that you can't have 16.5 kiddos.